In this video, we're going to continue to graph functions. We'll be graphing the cube function, the cube root function, and the square root function. In this first example, we have 2x cubed plus 3. Now you should recall that your parent function of x cubed has key points of 0, 0, 1, 1, negative 1, negative 1, 2, 8, and negative 2, negative 8. So your graph comes up through here, and your function looks like this. This is your parent function. So if you recall graphing your parent functions, we could use transformations and recall that this is the k value, which means that your function, this piece, is going to take all of your key points and move them up 3 spots. Or in other words, we're going to add 3 to all the y values. This number right here in front of the x cubed, this is your y distortion. Or in other words, we're going to take all of the y values and we're going to times them by 2 from your key points. So doing that, we would take each of our key points and we would times them all by 2. So we'd still have 0, 0. We would then have 1, 2, negative 1, negative 2, 2, 16, and negative 2, negative 16. Then each of these points would be moved up 3 spots. So 0, 0 would be moved up 3 spots. 1, 2 would be moved up 3 spots. Negative 1, negative 2 would be moved up 3 spots. 2, 16, that's clear off our graph. And negative 2, negative 16 is clear off our graph. And we'd move it up 3 spots. So we have a function that's coming up through here, curving and going up through here like this. Now, if you wanted to make a table with this, instead of using key points, you could still do that. If we plugged in a 0 to our function, zero cubed is 0, times 2 is still 0, plus 3 is 3. Notice we got the point 0, 3. If we plugged in a 1, 1 cubed is 1. So 2 times 1 is 2, plus 3 is 5. And we got the point 1, 5. So notice that we're getting the exact same points by plugging in numbers. Negative 1 cubed is negative 1, times 2 is negative 2, plus 3 is 1. So you could just keep plugging in numbers until you got enough points on here to draw in your curve. Here's our next function. We've got 3 plus 2 times the square root of x minus 1. Notice this is a square root function, and the graph of our square root function looked like this, with key points of 0, 0, 1, 1, and 2, 4. If we're going to use key points and transformations, notice that this moves everything to the right 1 spot. This is your k value, which is normally over here, plus 3. This is going to move everything up 3 spots. And this 2 in front that's being multiplied to the square root function, this is your y distortion, so all the y values will be times by 2 again. So if you're using key points, we'd take all the y values and times them by 2. And I did write the wrong key point here because remember we're square rooting, which means it's 4, 2, not 2, 4. 2, 4 is your key point for your square function. We're square rooting this. So our key point then would be 4, 4 after we've multiplied the y value by 2. Now I take these key points and we're going to have to move them to the right 1 and up 3. So I start at 0, 0, I go right 1, up 3. There's my first dot. Then I go to 1, 2, and I go right 1, up 3. And then I start at 4, 4, and I go right 1, up 3. And here's a graph of my function. Now again, you could always get these exact same points just by plugging in numbers for x. Notice if I plugged in a 0, I would be square rooting -1. And I can't square root -1, that's imaginary. So that doesn't actually work, it's undefined. So I do have to start at 1. 1 minus 1 is 0. Square root of 0 times 2 is still 0 plus 3. So I get to 0.1, 3. If I plug in a 2, 2 minus 1 is 1. Square rooted is still 1 times 2 is 2. Plus 3 is 5. So I get to 0.2, 5. If I plugged in a 3, I would be doing the square root of 2, which you could do. It's not nice. You'll end up with a decimal. Square root, if you plug in a 4, you get square root of 3, which is another decimal. But if I plug in a 5, 5 minus 1 is 4, square rooted is 2, times 2 is 4, plus 3 is 7. So I get 5, 7. I get the same points by plugging in numbers as I do by shifting these points. Sometimes it's faster to shift and adjust by the distortion. Other times it's faster to plug in numbers. It's really to whatever you prefer.